current drawn by three parallel connected resistors, R1, R2, and R3, when connected to a 20 volt supply is 2 amps. Is 2 amps. The question here is the current drawn by three parallel connected resistors, R1, R2, and R3, when connected to a 20 volt supply is 2 amps. If the value of R1 is 100 ohms and current in R2 is 1 amp, determine the value of R3 and calculate the power consumed by the parallel circuits. That is the question. And we have already started by identifying certain things in the question. The solution is there. The data is also identified. The energy supplied to the circuit is 20 volts. Current flowing around the circuit is 2 amps. R1 is given as 100 ohms. And then I2, that is the current flowing, is given as a 1 amp, right? Very good. Current flowing in R2, that's what it means. This should be R2. Okay, current flowing in R2 is a 1 amp, right? So we should take note of that. This should be R2, not I2. Okay, but that's notwithstanding, that is correct. I2 represents current flowing in R2. So what we need to do is to run a schematic representation of what this information is all about and see how they are connected, and then work accordingly and work things out accordingly. So the first thing we need to do is to show a simple schematic representation of the information given, and then try to connect it where possible according to what we are asked to do, right? So very good. We are going to have that schematic representation, and then it's going to be something very neat to avoid any sort of waste of time. We will take it that way and then see what we are going to do. That is very, very nice. Okay, so with this, we will look at this. Okay, so that is it. We are trying to draw the schematic representation of this. Let's remove what we are not, that's what is not needed here. And the next thing we are going to do is to put this information neatly as required of us, and then see how it plays out by the time we start calculating. Because with this pictorial representation, we'll be able to understand what actually is happening in the circuit and how current flows in such a circuit. That will be awesome by the time we come up with something great. All right, I think we are making headway, and we are having something neat at this point in time. Good. So we now have a pictorial representation of 3 resistors connected in series, in parallel, please, in parallel, not in series. We have a pictorial representation of 3 resistors connected in series. That is very, very important. Okay, so we have a R1. This is our R1. Already we know the value of R1, so we will not waste time here. We have our R2, right? We have our R2, and we know the value of R2. Good. We have also R3. We are going to find the value of R3, and then finally determine the current passing through R2 and the energy consumed by the entire circuit. So let's quickly complete this. Okay, this is the pictorial representation of the circuit. Good. We have the pictorial representation of the circuit. This point illustrates the energy point. So we have 20 volts. 20 volts. Good. All right. So this is 20 volts. Very nice. The current flowing in the circuit is represented here by this arrow. okay, and that is 2 amps. Yes, 2 amps, okay, 2 amps. Very good. Okay, so we have 2 amps there. The next thing we are going to do, we already know what we are expected to do here. We already know the value of R1, which is 100 ohms. The current flowing in the circuit is 2 amps, and then the current flowing in R2 is 1 amp. We are going to determine the value of R3 and calculate the total energy consumption in the parallel circuits. So we begin. What do? We need to find the total resistance, and that has to do with RP in the parallel circuits. RP is going to be something very simple that is going to be found by using Ohm's law, which is E all over the total current flowing in the circuit. All right, all over I. Good. I represent the total current flowing in the circuit. Good. So by the time we substitute wisely for E, which is the energy, is 20 volts, we write 20. All right. Then for current is 2 amps. 2 amps. All right. And we divide through. By the time we divide, 20 divided by 2 is going to be 10 amps. Okay, sorry, 10 ohms. I don't know what amps, why amps is always coming into my statements. 20 divided by 2, we are looking for resistance, so it's going to be 10 ohms because resistance is measured in ohms. Okay, all right, thank you so much. We have found the total resistance, okay, offered in the entire circuit, right? Good, very good. Now what do we do next? We need to find the what? We need to find the value of resistors connected in what? Resistor connected in value 3. That is the value of resistor 3. We also need to find the value of resistor 2. So how do we find the value of resistor 2? It's very simple, because there is some amount of current flowing into resistor 2. That's what we need to do, right? Current flowing into resistor 2 is 1 amp. So what do we do to find the resistor flowing there? All right, it's very simple. We state that current flowing is different, so resistor 2 can be found by R2 is equal to energy is the same. The potential difference across is the same, so we use 20, but current is not the same. We use 20 all over. The current flowing in resistor 2 is 1, right? Current flowing there is just 1. So it's very simple. The resistance of resistor 2 is just 20 ohms. Good, 20 ohms. All right, very simple. So we have found the value of resistors, the value of the resistance in resistor 2, 20 ohms. We keep it, okay? Very nice. Then we move on again. The next thing we are going to find is the value of resistor 3. The resistance offered by resistor what? 3. Good. So if we do that, we need to understand that resistor 3 can be found by using this formula as well. We need to know the value of resistor 3, and that can be found using this formula. Resistor 3, R3, is equal to E, because energy is the same, but current is different. So how do we now find current? Right? That's one thing we need to understand. How do we now find the current? Good. Now, what we need to do here is to recall that we have total resistance RP, we have resistance for R2, all right? Then we are looking for R3. That is it. We have R1, R2, okay? Then we have R3, whose value is not known. So we are going to find that right away. But before that, we need to understand the current flowing. If we can find the current flowing in R3, that means we can find the value of R3. Okay, so what do we do? Very simple. So the current here is what we need to know. So current flowing in resistor 1, first of all, current flowing in resistor 1, we need to find the current flowing in resistor 1. All right, then we already know the current flowing in resistor 2. So resistor 1, first of all, is R1. Let's know the amount of current flowing in resistor 1. Resistor 1 is 100 ohms. So let's see 100 ohms first of all. Okay. Now, how do we now find the current flow here? Of course, energy is the same. So what do we do? Very simple. Current flow is current flowing across resistor 1. Okay. Is going to be energy. Good. Which is 20 volts all over current flowing is what we are looking for. Then the resistor 1 is 100 ohms. Now we substitute wisely. For energy here we have 20. Don't worry, we're going to get everything 20. Then for current, for value of resistor 1 is 100. That's great, 100. And we're going to cancel out where necessary. So this will give us 0.2. Yes, this will give us 0.2. Okay, 0.2 amps. So the current flowing here across resistor 1 is just 0.2 amps. Okay, that is I1, if I should use that. Okay, current flowing across resistor 1 is 0.2 amps. We have found that. Good. If you have watched up to this moment, if you have found pleasure, value in this content, consider subscribing, right? Giving us some thumbs up, sharing with your networks, your friends, your students, share with your students, share with your fans, with your networks, with your family members who might want this for their children. Also, remember to put on the bell button for constant notification each time something like this is uploaded. Don't forget to drop in the comment box the topic you want me to teach next. Thank you. Let's continue. We have found the current flowing in resistor R1 is 0.2 amps. Good. Now we can now find the current that will flow into resistor 3, because current is not the same in a parallel connected resistors. Yes. So now we know the current flowing in resistor 1 and the current flowing in resistor 2. We can simply find the current flowing in resistor 3. What do we do? Current flowing in resistor 3 can be found by saying IR3. Okay, look at it. IR3 represents current flowing in resistor 3 is equal to total current. Total current is I, all right, minus the sum of current flowing in R1 and current flowing in R2. Okay, current flowing in R1 or I2. Okay, the summation of current flowing in R2 and then current flowing in R1, whichever way it comes. Okay, it could come R1 first or R2 first, so there's no problem with that. So what do we do? We sum. Total current is 2. All right, that's total current, 2 amps. We are going to subtract. The sum of this is going to be 1.2. So 1.2, if you sum current flowing in R2 which is 0.2, plus current flowing in R1, current flowing in R1 is 0.2, current flowing in R2 is just 1. So if you sum them, if you add them, it will give you 1.2 amps. By the time 1.2 amp is subtracted from 2, we have 1.8. Okay, 1.8 amps. So this is the amount of current flowing in resistor 3. It is time for us to use this formula. We are going to use this formula. The formula I am putting in a rectangular box. We are going to use this to find the value of resistance 3. Okay, that is resistance 3 now is going to be energy once again. Okay, energy is 20 ohms, right? Good. And then over 18 over 10. Yes, 18 over 10 is simply the same thing as 1.8. 18 all over 10. So we are solving this in real time with our calculator. So what we need to do is very simple. We do here is 20 all over 1. 20 over 1, right? Good. Times 10 comes up. All right, 10 comes up, and then over 18. Good. So that's very simple. That's very simple. So what do we do? Very simple. 2 can go. This is 200 over 18. 200 all over 18. All right. I'm going to make sure I squeeze in everything here. 20 times 10 is 200. Okay. Then over 18. Let's see how it goes. So we have 18. Good. With this, we can now say if 2 divide 200, we get 100. Okay. Then 2 divide 18, we have 9. Good. We have 9. So we go again. 3 divide 100 is going to get 33 point something. So let's just leave it there. R3 is 100 over 9 ohms. Good. So that is the value. We can simplify further to have the fractional remnant or the decimal remnant. Now we have this. How do we now calculate the energy